Welcome to Lecture 5. This week we continue with the second part of our topic, collection of solid waste. And we begin by looking firstly at the labor requirements. So if you recall, in our previous lesson we talked about the hauled container system, that's the HCS. So we'll be looking at the specific personnel requirements for the hauled container system. Right, so firstly we need to note that for the whole container system, if you recall the whole container system, that's where usually it would involve the removal of the usually large containers from the place where it has collected quite a large volume of waste. The entire container which has been filled will be removed by a vehicle, taken to a place where it is emptied, and then returned, the empty container returned. So for this type of collection system, usually we will need a single collector driver. So that would be an individual who will function as both collector and driver. So the collector driver is responsible for the following. He's responsible for driving the vehicle, loading full containers onto the collection vehicle. So bear in mind, the loading process of those full containers would be very mechanical, so there would not really be any urgent need for additional labor. He's also responsible for emptying the contents of the containers at the disposal site and also redepositing the container. So the entire process is usually very mechanical. However, in some cases, for safety reasons, you may need both a driver and a helper. So if you are very concerned about safety, it is advisable that you also have someone else available for assistance, because even though it is a mechanized system, that can also present a danger in cases where there's possibility of malfunctioning of equipment, etc. So what would the helper be responsible for? The helper would be responsible for attaching and detaching any chains or cables used in the loading of the containers, loading it onto the truck for transportation. He would also be responsible for unloading containers on and off the collection vehicle. So these are some of the responsibilities that the helper would be carrying out. The driver now is responsible for the operation of the vehicle. So not only driving the vehicle from point A to point B, but remember, even the loading process will require the driver to carry out certain mechanized processes from inside the vehicle in order to assist with attaching the containers to the vehicle. So one person would be inside the vehicle, which would be the driver, and then the helper would be outside carrying out whatever tasks in terms of attaching and detaching cables, etc. A driver and a helper should always be used, that is, two personnel should always be used where hazardous waste are to be handled. And of course, if they have to handle hazardous waste, there will be specific precautions as to how that should be done, and it would also involve it would also necessitate the use of PPE in order to handle the equipment. Sorry, not just the equipment, but the hazardous waste itself. So let's look at the labor requirements for the stationary container system, the SCS. So if you recall the stationary container system, this one is typical of what is carried out in residential areas, where you would put out your containers on the curbside and the collection vehicle will come and they will empty it and take it back. So the requirements personnel, this will vary depending on whether or not the collection vehicle is loaded mechanically or manually. Remember, we made reference to that in the previous lesson, that you can have manual loading of your waste, where the helpers, they will pick up the bins and empty it into the truck, which we are most familiar with, Or in some cases you may have a vehicle that is equipped to mechanically attach to the bins, lift, empty, and replace it. Right, so we have those two options. So therefore, depending on which one is used, that will determine the personnel requirements that are needed. So the requirements now for the mechanically loaded stationary container systems are the same as the HCS. Remember, we just looked at the whole container system, and that would be a helper and a driver. So where a helper is used, the driver often assists the helper in bringing the loaded containers, which would usually be mounted on rollers. Remember, this is a mechanical collection system. So loaded containers which are mounted on rollers would be taken to the vehicle, attached, emptied, and then they will return the empty containers. Now occasionally a driver or two helpers may be used where the containers to be emptied must be rolled, if it's very large, to the collection vehicle, particularly where your storage area appears to be in inaccessible locations. For example, it may be in an alley. Remember, the vehicle would not be able to drive down the alley because it's much too narrow, or inside little gaps or lanes. So we have a lot of these kinds of layouts and topography around Trinidad, so you would often be faced with this kind of scenario. Let's talk a bit about the layout routes now. So remember, we have been talking about collection system, and an important part of waste collection is route design and routing, right? So once you have made a determination as to what type of equipment you need and what your labor requirements are, the collection routes must now be laid out, and this is very important because you need to have this done efficiently and effectively. All right, and this is done so that both the workforce and the equipment can be used effectively. You don't want, for example, this is a question we need to ask here. What are some of the possible consequences of improper route planning? For example, you can have idling of some resources while others are overburdened. For example, if you don't plan your route effectively, you may find some trucks and crew are not being used while another is being overburdened and overworked. Also, if your route is not planned effectively, you can have a buildup of waste when it's not collected on time. So you may have, let's say, if you didn't plan your route properly, if you needed to have 2 or 3 collection trips to a particular neighborhood in 1 week, if it was not properly planned, you determined that only 2 was needed, so you will have that buildup of waste occurring unnecessarily because of an ineffective route plan. Okay, let's look at some basic guidelines for route collection. So where you have existing policies and regulations that provide guidelines for identifying collection points and frequency of collection, you must identify these existing guidelines and regulations, because this is the starting point. This is where you want to begin, because if you have existing policies and regulations, more than likely these would be based on international standards, so they'll be fairly rigorous in terms of their design and implementation. So that's a very good place to start. Then you can also look, we also want to look at existing system characteristics, such as what is your crew size? Is your crew size sufficient to meet the needs of your collection route? What about the vehicle types? Are your vehicle types sufficient as well? We looked at a few vehicles before. Do you need a standard size vehicle? You want to consider what is your waste generation rate. Do you need to provide a collection vehicle of a larger size? So all of these things you would want to consider. You'd also want to say, wherever possible, your routes should be laid out so that they begin and end near arterial streets. So arterial streets, for those of you who don't know, arterial streets would be like minor streets, streets such as what you would consider in residential areas, for example, as opposed to a main road or a highway, right? So you'd want to begin and end near the arterial streets using topographical and physical barriers as route boundaries, because these would be natural and man-made boundaries that would not allow you to cross or drive over them. For example, drive over a river without a bridge, etc. Additionally, in hilly areas, routes should start at the top of the grade, the top of the hill, and proceed downhill as the vehicle becomes loaded. And logically, that will tell you is because as you begin to fill the vehicle will become heavier and heavier. So it would make sense for you to move in a downhill direction so that your movement could be facilitated by gravity. Additionally, your routes should be laid out so that the last container to be collected on your route is located nearest to the disposal site. So in other words, you start furthest away from the disposal site and end nearest to the disposal site. For example, if your disposal site is a landfill. Waste generated at traffic congested locations should be collected as early in the day as possible. For example, where you have traffic congestion, the movement of the vehicle through that traffic congested location it's going to be difficult, not only for the truck, but it's going to be an inconvenience for the other travelers on the road, drivers, etc. So you want to do it as early in the day as possible to avoid some of that congestion. The sources at which extremely large quantities of waste are generated should be serviced during the first part of the day, particularly in a place like Trinidad and Tobago, where there is a lot of heat, etc. You don't want to leave that large volume of waste during that heat for decomposition to begin to take place. You also want that the containers would be empty at the start of the day as well, so because we know that the waste would be generated during the course of the day, so you would want to have those dealt with in the first part of the day. Then also we have scattered pickup points. This is where, for example, we have small quantities of solid waste that are generated. So these scattered pickup points that receive the same collection frequency should, if possible, be serviced during one trip or on the same day. Alright, so if the frequency of collection is twice for the week, you want to make sure on that one trip, where possible, that you could service all those scattered pickup points. Now let's look at scheduling of the collection vehicles. So this scheduling of the collection vehicles, this is something that would be done at your solid waste management agency, right? So you will have a master schedule for each collection route that would be prepared, and within that agency you would have the engineering department. Usually they will have a specialized software that will facilitate efficient routing of your collection system. And then of course the process would also be facilitated by your transportation dispatcher. So once the route has been determined, the transportation dispatcher will facilitate the scheduling of what trucks should go out, what crews should go out, etc., and when they should go out. So a schedule for each route, so you can have several routes in one day, even within one neighborhood. So what will happen is a schedule for each route, which includes the location and the order of each pickup point to be serviced should be prepared for the driver. So in other words, the driver is not going out there blindly. They know exactly where they're going to, where they start, where they stop, and where they finish. Additionally, a route book should be maintained by each driver. So the driver will have this route book with him. The driver uses the route book to do the following. That is to check the location and the state of the account. In other words, at this particular location, has this location been serviced at this time on this date? The route book is also a convenient place to record any problems with that particular route. And also the information contained in the route book would be useful in modifying the route collections. So really what we're saying is any problems that would have been identified in that route book can be utilized in order to improve on the collection route. Okay, so here we have, this is not exactly a route, but this is a scheduling of service areas. So these are two examples that we have here. So for example, each of the color codes are collection areas. So we see area 1, for example, is this color here, and we see that area 1 is serviced on Fridays for trash, also on Fridays for recycling material, and Monday is when they will come to collect yard waste. And then we can see similar kind of strategy applied for the other areas. We have area 2 here, which is this blue area, area 3, this is area here, area 4, and area 5. So we have 3 types of waste that are collected: trash, recycle, and yard waste, and there are 3 times that they would be scheduled to collect. Over here we have another type, those similar type of scheduling, and we see we have trash collection and recycling collection that have been scheduled. So for example, we see this area here on Monday they collect trash. Also we see that area, with the same color, we see that area on Wednesday they collect recycling. So that's Monday trash, recycling Wednesday. Alright, let's look at one more. Tuesday is the yellow, Tuesday is trash, Thursday is recycling. Okay, so let's move on. So now what I want to do is I want to go through some simple route calculations for you. This is typical of some of the type of calculations that will have to be determined in order to establish your routing. And we're going to look at the following 4 questions. We're going to determine the total number of residences from which wastes are collected within a particular area. We're going to look at the compacted volume of waste to be collected each week. So that's the compacted amount of waste that would be collected from the area in a week. Number 3, we're going to determine the number of trips that would be required per week for waste collection. And then lastly, we're going to determine the average number of residences from which the waste are to be collected each day. And this information would be necessary as well in terms of determining and projecting waste generation rates as well. Okay, so before we can do anything, we want to look at the following data where we make certain assumptions. So we start with these assumptions. We assume that the average number of occupants per house is 3.5. Also, the solid waste generation rate per person per day is 1.6 kilograms. We're still to determine collection frequency. We assume that we have curbside collection, so we know what our curbside collection is. We also assume that our collection crew size is 1. Our vehicle capacity is 20 cubic meters, and the compacted density of solid waste in the collection vehicle is 325 kilograms per cubic meter, right? So we're saying the vehicle can hold this much, but the compacted waste that it can hold is this. We also assume that there are certain route constraints, that is, you're not allowed to make any U-turns on the street, and also the collection along the street side would be on the right hand side. So that is because this example we are using is a North American example, right? For us here in Trinidad, you would assume a left hand side collection. Okay, so this is an example of what our route layout might look. So let me explain a few things that's going on here. For example, we have two route layouts on this chart. We have route 1, which starts here and ends here. So let's just follow the route very quickly. So if it starts here, remember we can only go in one direction, no U-turn. So if you follow with my cursor, this is the route. So this is route 1. Alright, still following with me. And the route ends here, right? Similarly, we have a second route. The second route starts here and it ends here. Now I'm not gonna trace the entire second route for you. You can do that yourself. But please note that once the route has ended, both routes will connect in this direction in order to head to the disposal site. Additionally, the other information contained therein, we see some numbers in each of the blocks. So each of those would be a residential block. So these are the number of residences along each block. We have 2, 6, and 12. For example, it means that we have 2 houses on this side of this block, 2 on this side, 6 on this side, and 6 on this side. And we see we have different size blocks. So now that we understand what the route layout looks like, let's do some calculations now. Right, so the first question we asked was, we wanted to determine the total number of residences from which waste are to be collected. So we see that, let's try to understand what these numbers mean, right? So here we see 10, 16. Let's just go back to the chart. So for example, we have 12, 14, 16. So all the blocks like this, we are saying we have 10 of them. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So we go back here. So that's this is what 10, 16 is. So that means then that we have 4 of 36. Which are the 4 of 36? That's everything else. That's 1, 2, 3, 4. And then we also have 1 of 28. So when we add all of this together, we derive 332 residences in total. The next thing we had to do was determine the compacted volume of solid waste to be collected per week. So this is where we work in some of our assumptions now. So we know the total number of residences, 332. We multiply that by the average number of persons per residence, right? So we know the total number of people. We multiply that by the amount of waste that would be generated by each person per day. And then remember, we're calculating for a week. So it's a 7-day week. We multiply that by 7 days. So that number we then divide by our compacted volume of solid waste. If you recall, this was a number we were given, the compacted density of solid waste in the collection vehicle, right? And the number that we derive, the value that we derive for our compacted volume of solid waste to be collected for the week is 40 cubic meters per week. Next, we want to determine the number of trips per week that we need. So if this is the amount of compacted volume of solid waste we collect per week, right, we also want to divide that by the capacity of the vehicle, capacity of one vehicle. So that means if we divide 40 cubic meters by 20 cubic meters, remember the 20 cubic meters was also an assumption that we made. It means then that we have determined that we need 2 trips per week in order to facilitate that waste collection. And then we want to determine the average number of residences from which waste are to be collected each day. So we have our 332 residences. We divide that by the number of trips, which would be 2, right? So in other words, how many residences can we actually collect waste from in one trip? And that will be 166. Okay. And of course, the last point here really it just gives us a note that the layout collection routes, which would have been determined by trial and error, utilizing the route constraints that we mentioned, we have 2 routes that have been determined, which we saw in the previous slide. Okay. So at this point, I want to thank you for joining me for today's lesson. And I would like to ask you to please proceed to the activity for this week. Thank you.